Hello, my name is Mike Kehoe, and today I'm going to talk about the journey to threat management, all the way back from key locks to full threat management. So it'll give me around 8 or 9 of your minutes, and let's follow me on this journey. So back in the day, in 1984, when IBM introduced its new PC, it actually realized that it could have an issue with vulnerability. So it put in a key lock, and this locked out the keyboard. And the quote said, "We're going to let our executives sleep easy at night." That was 36 years ago. How do we get to today? Which is now we have to look at all our packages running through our networks and even looking at maybe 2 to 3 million events per second. There was a lot to do between 1984 and today. Let me show you how we got here. So initially, we started with PCs and we just locked them, made them secure. We even locked our disk boxes. And then we moved on and we started to add simple passwords or encryption to our PCs around the 90s. And then we moved on again and we started to bolt on various types of security, depending on what we were trying to protect. Was it databases, servers, and so on and so forth. But it was quite limited. But as we progressed into the 90s and then we started to see the boom of the internet, we really had to have what was called a 3-tier defense, or even in recent years we call the immune system, where we try to protect everything and monitor everything. Now we've moved on and where now computing has become ubiquitous. Be on your watch, on your phone, in your car. Everybody needs to be connected and every system needs to know who you are, which is huge challenges for security. And of course, going forward with AI, with blockchain, with cloud, we're going to add more complexities to cybersecurity. Because what I think in what happened that really caused us to think was back around 2017, where the revenue generated from cyber aggression and cyber criminal activity surpassed that of the illegal narcotics trade worldwide. Clearly, this has gone mainstream in criminal activity and cyber aggressors. So let's go all the way back to 1984, where one would have a computer, it would sit there, and how vulnerable you might be is that if the computer was stolen, or maybe the computer got damaged by a house fire. So what we did is we started to connect computers to other computers, and we used token ring and we passed data back and forward. And by doing this, we were able to make sure that if anything happened to our computer, somebody else might have had our files. But we've added a new vulnerability here. We've added insider. Imagine if that person we gave our files to decided to use those files for their own personal gain. And even with the connection, could we have had a man in the middle who could get into those types of cabling? So we move on and we start to look at add more and more nodes to what's called a switch. And a switch allowed us to connect many computers on a single little network together. And we used to use token ring passing, where one computer would become the king of the network, and that computer then would decide who gets to see data and where the data is shared. And as this evolved through the 80s and into the early 90s, we started seeing maybe the engineering department, the HR department, the operations department, all started to build their own little small networks. So the rise of the network and the local area network started to come about. But of course, we started to see much more devices and much more intelligent systems coming on board, such as servers, such as storage, such as mobile devices, and again, much more personal computing been added to our networks. So we had to connect them all together and we used what was called a router. And a router will let networks talk to each other. So if I want to go from my PC to my shared data, the router will say, "Oh, I know where you're going." Or if I want to connect to the server for an application, the router will fix. So this is the beginning of network topology, where we have nodes sitting on switches, sitting on routers. But then the big thing came along in the mid-90s, where the internet became part of our network. So we started to connect routers to the internet, and we could talk to wide area networks, or networks in other geos or other countries, and so on and so forth. So now, considering what happened next, reality struck. It was, unfortunately, there are criminals, there are cyber aggressors and fraudsters out there, and they saw this newly evolving network and the chance for them to abuse it. So we then had to think about how do we lock up our nodes using endpoint detection? How do we then lock up our servers using identity access? How do we lock up our data using encryption? Then how do we make sure that even if people are able to get over these defenses and they move around our networks, how do we do detection in this, which we called IDP or IDS, which was intrusion detection or intrusion protection. And then finally, we had to start to lock up our mobiles, and then we had to put a firewall in. We had to make sure that we didn't let the outside world come in, not permitted, to our networks. And this is where the firewall came from. So this is all transactional tier one. What we're trying to do is we were trying to find aggressors or issues in real time and stop them. And this is, of course, the very first step you have to accomplish when you're trying to secure your environment. But it doesn't stop there, because now you have to move into what's called transactional. So what you do is you take your data from all these devices, such as your switches and your routers, your servers, your data, and you take what's called their logs, because you have to examine those logs to make sure that there has been no unauthorized or abnormal behavior in those logs. And we use what's called device support modules, which kind of allow us to translate those logs from many, many different manufacturers into a standard language that we can understand. So when we take those logs in, we have to collect them. So we use a collector, and it collects huge amounts of these logs, running many, many hundreds, thousands, if not a million times a second. And we call these EPSs, events per second. So when we collect, we're able to parse. And parse, we're able to make sure that they all look and feel the same. And then they're sent up to a processor. And this processor starts to run rules to say, well, if I've got information from one log and from another log, does that make sense? Am I looking at a brute force attack? Am I looking at a piece of malware that's worming its way through my network? So this is the collector. We're still at correlation level. We're trying to look at different parts of data, different elements, and fuse them together to see an anomaly. We're not quite at threat management yet. Then we start to move into the SIEM, the Security Information Event Management. And of course, as our processors start to see anomalies, it generates offenses, and these offenses head on into our SIEM, where we start now to manage. We are now heading into the world of threat management. So to help the SIEM, we have to then consider, well, once we see an anomaly, what do we do? So we get into response management, the who, the when, the what, the how. We should have well-trained responses that we know how to execute as soon as we see an offense that can cause us harm. We actually have to use our partners, and IBM has many, many partners that actually help us build a full threat management system. We then have to have investigation and hunting. So if something has got onto our network and has concealed itself so well, we'll have to maybe take a look at the deep package inspection. We'll have to go in and take a look at link analytics to see, well, what's connected to what, over what timeline, how did it progress through our network. We then take a look at risk management. And risk management says, well, has any new device entered my network? Do I know about it? What's it doing? And so on. So I'm trying to baseline, and I'm trying to keep my baseline clean. And risk management helps me do that. Getting into threat intelligence and OSINT, which stands for open source intelligence, what I'm looking at is, what is happening in the threatscape? Do I need to know about it? Is this affecting my organization? So I'm bringing in external data, and I'm cross-referencing it with what I know and what I'm doing, and making sure that I haven't missed a vulnerability. The next one I look at is Network Manager. Of course, we have packages moving up and down our network, but inside those containers are content. What's inside that content? Is it malware? Is it a denial of service bomb? We have to know that. So we're getting into package inspection. We move forward and we try to say, well, of course, this is a very difficult thing to do sometimes, and time is of the essence when our network has been compromised. So we can take a look at artificial intelligence. Is there systems out there that help me to analyze the offense faster than I can do it, because time is the essence? I then get into user behavior. This mightn't be an external cyber aggressor. It might be an internal aggressor. It might be somebody who has a grievance against my company, or even just is ignorant to the fact of how they protect the company's assets. And I have to take a look at user-based analytics to see, is the threat coming from internal because I see abnormal behavior by one of my own. I then take a look at vulnerability management, and this is very closely linked to risk management, where it says, right, I've got a new device in the network. I'm okay that it's not somebody's aggressor who's put it on, but it's one of my own team. But have they configured it correctly to my security or to my policy level? So my vulnerability manager will take a look at, well, keeping the baseline clean because everything's been configured to policy or to certification. Then I start taking a look at incident forensics. Incident forensics means there is a scene of the crime. Unfortunately, it has caused me harm, but I need to understand it so I can recreate, using packages, the scene of the crime, which means I have to bring a huge amount of data together, but I can look at maybe instant messaging, emails, web access, and so on. And then finally, I have to manage this under a dashboard, which all comes together. Now, this is where threat management really comes into its own. How do I know what I should be doing, how I should be doing, when I should be doing, what I should be doing, with all these very strong and powerful functions? Because at the end of the day, my job is to protect my environment. But my story doesn't stop there. I could continue because we've talked earlier, we've talked about our endpoint protection, we've talked about our network protection, we've talked about encryption, we've talked about DevSecOps. In other words, making sure that any new product or any new application you put into your environment has got complete security clearance. We actually have done a check on the source code. We also look at access management, who has access to what, are they privileged users, and so on and so forth. Again, these sit in the tier 1 and the tier 2, which is the transactional or the correlation. But now you have to get into more proactive stance, which you have to look at penetration teams. Can I invite subject expert teams into my environment and see can they break into my network? And sometimes I won't even tell my network analysts or administrators that they're in the building. I will see can they find my vulnerabilities. And in the case that I do have a cyber breach, of course my operation might be something that I'm very comfortable with, but I'm not comfortable with full-scale cyber defense and investigation. So I have to bring in an external team, and that's okay. It's a response team. The other thing you have to think about is, well, of course I'm generating huge amounts of data. Well, what do I do with it? Because even though the data isn't relevant today, it might be relevant tomorrow. So I have to think about cold storing it. Where do I store that data when I'm finished looking at it in tier 1 or tier 2? Cloud and cloud packs are going to have a major, if not currently having a major impact in our strategy going forward. Rather than having all this data being processed and been collected locally, why don't I ship it to a cloud? And why don't I collect my data and do all my analytics? And then of course all my additional threat hunting, which is the risk of the vulnerability or the deep package inspection. And then cloud packs help me to do that and break it up into purpose-built applications that can sit straight into my cyber environment and to my cyber strategy. And finally, HA&DR, high availability and disaster recovery. If I lose my defenses, I am 100% vulnerable. So I have to decide what is the must-haves, the should-haves, or the nice-haves of my network, that if something goes down, I hot swap and a new system takes over. So there's quite a lot here to unpack. And that's what threat management is. It's not just a collection of products. It's how well you have your people, process, product, and policies aligned for the most effective and efficient defense possible. A defense that has to constantly evolve with the threatscape. And IBM can help, because if we draw back the curtains, you can actually see that we are probably the only supplier out there of a full end-to-end solution, working with our own products, our own teams, and also working with an amazing amount of partners. But we can go end-to-end on full threat management for your organization. So before I end, I'm going to explain how this works from a theory point of view. I explained tier 1, which is transactional, tier 2, correlative, and tier 3, which is investigative. And by putting all these tiers together and managing them in an effective way, you are putting a certain level of threat management out there. And let's hope that that level of threat management is above the current level of threats. We call this an asymmetrical advantage. But if it's not, you generate what's called a vulnerability gap. And a vulnerability gap leaves you open to attack, whether it's at a device level, network level, account takeover, firewall, so on and so forth. And how well can you discover that, and how well can you understand it, prevent it going forward? And that's the vulnerability gap. And unfortunately, with the threatscape out there becoming more and more aggressive, if we continue to do nothing and stay as is, our vulnerability will grow. Not a function of us, but a function of the threatscape and the function of what we do in the threatscape. So our job is to zero the vulnerability gap. And zero the vulnerability gap is a very, very difficult thing to do because there's no such thing as perfection. But our job is to ensure that as we monitor, manage, coordinate all our process, people, products and policies, that we are getting so close to the vulnerability gap that it is next to impossible for the cyber aggressors to find an open aperture to come in. And this constantly changes. You have micro vulnerabilities jumping up all the time, and our job is to stop them and make sure that they don't expand. So if I was to summarize, having your tier 1, tier 2 and tier 3 and understanding what is involved in those, having your proactiveness, and then continual process improvement to zero that vulnerability gap is in essence what threat management is all about. So if I was to summarize this before we finish, threat management is an holistic approach to all cyber defense activities to ensure that we can zero the vulnerability gap in an ever-evolving cyber threat space. So with that, I will thank you for your time. Of course, there's a lot more here to talk about, and I would welcome an opportunity for you to invite myself and my team to really show you what IBM can and has done in the space of threat management. Thank you very much.